Welcome. This is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York, and this is Exploration. Every week on Exploration, we discuss the fascinating world of science, and today we're going to, answer emails. And I get a lot of emails from listeners, and there's no way I can answer each one. So I think what I'll do is try to group them together today and try to answer them. For example, black holes. We've been talking about black holes recently, but, if black holes are invisible, then how can you possibly photograph something that's invisible? And what exists on the other side of a black hole? And for that matter, why didn't the late Stephen Hawking win the Nobel Prize for black hole research? And then I often get asked the question, where did life come from anyway? Did it come from the oceans? Did it come from the seas? Did it come from outer space? Well, the whole concept of panspermia has been getting a lot of new attention recently because of the fact that we've been tracking meteors and comets from outside the solar system. Things that were once considered to be impossible, we now consider to be ordinary. And for that matter, let's talk about the space program. Many people believe that we're entering the second golden era of space exploration. But what about the cost? What happened to the first great era of space exploration? It simply cost too much. What has changed? And the threat from outer space, how serious is it anyway? And then we'll say a few things about DNA. Recently, there have been a lot of stories about DNA in terms of, sequencing ancient animal DNA, animals that were frozen thousands of years ago. And for that matter, is it possible that one day we may be able to bring back the mammoth, bring back ancient animals that died tens of thousands of years ago? And for that matter, what about the dinosaurs? Well, let's just jump right into today's program where I'm going to answer a lot of the emails that I get. I got a lot of emails recently about black holes. One listener says, wait a minute, something's not right. After all, black holes are black. That's where the name comes from, right? They're so massive that even light itself cannot escape. But, smarty pants, if black holes are invisible, then how can you possibly photograph something that's invisible? Well, that's a very good question, and you're absolutely right. Black holes are invisible. They are objects so massive that even light itself cannot escape. In fact, that's why they're called black holes. So the photographs that we got from M87, which is 55 million light years from the planet Earth, is the shadow, the silhouette of an object which weighs 6.5 billion times the mass of our sun. It is a huge monster, and it's not even in our own galaxy. It's not in the Milky Way at all. It's outside the galaxy, at the heart of the galaxy M87. And so the photograph that people have been seeing is the shadow, the silhouette of the black hole. And when you see the glowing red ring around it, that's basically hot gas that's swirling around the black hole. The black hole is so massive that it eats entire star systems for breakfast and won't even burp. And speaking about eating up star systems, another question I get is, if black holes eat up everything in sight, then how come they don't gobble up the Earth? What prevents the Earth from being eaten up by a black hole? Well, first of all, there is a black hole in our own backyard. Tonight, go outside. Look in the direction of the constellation Sagittarius. That is the galactic center of the Milky Way galaxy. By rights, there should be a fireball that outshines the moon, that comes out every night, and it represents the center of our own galaxy. And at the center of the galactic nuclei, there is a raging monster, a black hole in our own galaxy. Now, very soon, astronomers are going to announce that, yes, they too have photographed that black hole as well. The black hole at the center of our own galaxy weighs about 4 million times the mass of the sun, and it's small compared to the black hole at the center of M87. So why aren't we eaten up by the black hole? Well, the answer is very simple. We orbit around the black hole. It turns out that if you are outside what is called the event horizon, the point of no return, the event horizon is a sphere surrounding the black hole, and if you were to fall through the sphere, then of course you would never come out again. However, we orbit outside the sphere at a very safe distance. In fact, according to Einstein's equation, outside the event horizon of a black hole, the gravitational field is very similar to what you would expect using ordinary Newton's theory of gravity. And so that's why we don't fall into a black hole, and that's because we safely orbit around the black hole. And then another question I get is, well, when you visit a planetarium and you listen to children talking about black holes, they ask the question, well, if everything falls in, where does it go? What's on the other side of a black hole? That's a good question. And the short answer is, we don't know. But there are theories that explain what might be on the other side of a black hole. In 1915, Einstein proposed the theory of gravity called general relativity, where he said that gravity is really an illusion caused by the bending and curvature of space and time itself. So, about a year later, Professor Carl Schwarzschild found a solution of Einstein's equation in 1916, which gave us the black hole that we talk about today. However, in 1963, yet another exact solution of Einstein's equations was discovered by mathematician Roy Kerr. And his theory showed that Einstein's theory for a rotating black hole, the black hole collapses not to a dot, as in the 1916 black hole, but the 1963 black hole is rotating and collapses to a ring of neutrons. And if you fall through the ring, you do not necessarily die at all. In other words, the singularity may not necessarily kill you. In fact, you can work out the mathematics and show that, yes, under many circumstances, you can go right through the ring and not be killed. So what happens? Well, Roy Kerr found that if you go through the ring, you wind up in a parallel universe. That's right, a parallel universe. And if you go back into the ring and enter it a second time, you enter a second parallel universe, different from the previous two. And if you go through the ring over and over again, it's like going in an elevator in an apartment building. If you're in an apartment building and hit the first floor, you can look around. Then if you hit the second floor, well, the second floor looks very much like the first floor. You go to the third floor, and the third floor looks very much like the first floor and the second floor, except, of course, there are slight variations. Well, Roy Kerr found that, yes, a black hole does not necessarily have to end at the singularity. It can be a gateway to many parallel universes. So what's the catch? Well, first of all, this is very similar to Alice's looking glass. We all know that when Alice stuck her hand through the looking glass, her hand wound up on the other side of the universe in Wonderland. Well, the looking glass is like the solution found by Roy Kerr. But what's the catch? Well, the catch is, first of all, a lot of radiation falls into the black hole, and that may disturb Einstein's solution, which assumed that everything was concentrated in a simple ring. Second of all, we have to calculate quantum corrections. It turns out that Einstein's theory is simply not complete by itself. Einstein's equations really break down at the center of a black hole and the instant of the Big Bang. So for these very extreme areas, the location of the black hole and the origin of the universe, for these very, very strange environments, Einstein's equations break down, and we have to go to a quantum theory of gravity. At the present time, there is no quantum theory of gravity that is universally recognized and has been tested. The leading candidate, which is just a theory, untested, the leading candidate is string theory, which is what I do for a living. That's my day job, working on string theory. And string theory says that, well, yes, it's possible that there could be multiple universes out there, but you have to calculate radiation. Radiation effects may destabilize the black hole or perhaps keep the gateway open. We don't know for sure because we don't have a theory of everything that is universally accepted by all physicists. So the short answer is yes, there is a theory that there could be a white hole on the other side of a black hole. As matter flows into the black hole, is blown out the other end as a white hole. The catch is it is not universally accepted by all physicists, and it has not been experimentally tested. I should point, however, that the Large Hadron Collider outside Geneva, Switzerland, is eventually going to be replaced by the next generation, which may, in fact, be able to prove the correctness or incorrectness of string theory. The Japanese, the Chinese, and the Europeans, three groups, have proposed a successor to the Large Hadron Collider, the gigantic atom smasher outside Geneva, Switzerland, and it may be possible to detect dark matter. Dark matter is a form of matter that is invisible. It surrounds the galaxy, and we're clueless to figure out what dark matter is. Maybe, just maybe, dark matter can be predicted by string theory as the next vibration of a tiny string. That would nail it to the wall. And in the coming years, perhaps we will be able to find funding for a large atom smasher that may, in fact, be able to detect the presence of dark matter and prove or disprove the correctness of string theory, and then settle once and for all the question, what happened at the center of a black hole? And for that matter, what happened before the Big Bang? A theory of everything is also a theory of the Big Bang, and it should tell us whether or not there are other universes before the Big Bang. This is the multiverse idea. The multiverse idea is quite simple. It simply says that our universe is a bubble of some sort. It's expanding. That's the Big Bang theory. But our bubble coexists with other bubbles in an ocean, a bubble bath of other universes called the multiverse. Another question I get in the mail is, well, where did life come from anyway? Did it come from outer space? Did it come from the mountains, the air? Where did life originally come from? Well, if you take a look at the fossil evidence, we can get fossil evidence going back roughly 3.5 billion years. However, we have to realize that when the Earth was first formed, we enter the age of meteor impacts. So even if life got started, let's say, in the oceans, many times the oceans probably were boiled off by meteor impacts long time ago. But if the first DNA gets off the ground 3.5 billion years ago, there wasn't enough time for DNA to naturally gestate in the oceans. That's why some people, including the legendary figure Fred Hoyle, a leading cosmologist, that's why he believed in the panspermia theory. So at the present time, there are two theories as to where life began. The first theory is the one most commonly accepted. Life started in the oceans someplace or in a lake. It took place at the bottom of the oceans where there is energy coming from vents, volcano vents, hot water thermal vents, because this is an era before photosynthesis. Life requires energy. Energy from our life comes from plants, which get their energy from photosynthesis. But the very first cells did not have the mechanism to store energy via photosynthesis. However, volcano vents would give an immediate supply of energy to get hydrocarbons to create the first DNA molecule. However, the other theory says that maybe life came from outer space. And that theory has actually been gaining some verification in the forms of meteors and comets from outside the solar system. Now, when you see a meteor, it's probably debris from the asteroid belt. The asteroid belt is between Mars and Jupiter. A lot of the asteroids there have orbits which eventually will intersect with the planet Earth. And so a lot of the meteors are caused by asteroids that fell out of the asteroid belt or the tails of comets. And we now know that meteors from other solar systems can actually reach our solar system. This was once theorized, but now we actually find evidence of this. How do we detect a meteor or comet from another solar system? Well, it's actually easier than you think. What you do is you get the trajectory of the known comets and meteors, run them through a computer, and then run the videotape backwards. We have Newton's laws of gravity, and therefore we can run the videotape backwards and determine where these things came from. And bingo, yes, we are finding that there are meteors that NASA tracks. When you run the videotape backwards on these meteors, by golly, they came from outside the solar system. And we now know that DNA can survive in outer space. Germs, bacteria, tiny microorganisms can actually survive on the surface of our space probes. Once again, contradicting common sense. So it means, therefore, that maybe, just maybe, life came from another planet or maybe even outside the solar system. For example, one day we're going to go to Mars and we're going to analyze the rocks on Mars and compare them with rocks that we think came from Mars that were blasted out of Mars by meteors and eventually drifted and landed on the Earth. That's right. Meteors from Mars have actually landed on the planet Earth. We know this because we look at the mineral content, and it matches exactly the mineral content of Mars. We looked at trapped air bubbles inside these rocks, and bingo, once again, a perfect match with the chemical composition of the atmosphere of Mars. So we do know that Martian meteors have, in fact, landed on the planet Earth. And scientists, looking at the rocks using a microscope, have found wormy-like structures inside the rock. Now, this is still controversial. The people who found these worm-like structures said that maybe, just maybe, is fossilized evidence of microbial life. Other people say not so fast. Maybe it's just crystals, crystalline forms of minerals on Mars. We don't know for sure, but the point we're raising is it is conceivable that life started on Mars first, then was blown into outer space by a meteor impact. These meteors drifted for millions of years in deep space and then finally landed on the Earth. So the next time you want to see a Martian, simply look in a mirror. Maybe you are the Martian. And then another question I get in the email is, well, a lot of people have been watching the Jurassic Park series. Is it possible to bring back the dinosaurs? Well, first of all, this is a serious question being asked at Harvard and other places where they believe we can bring back Ice Age mammals going back tens of thousands of years. For example, because of global warming, the tundra of Russia is gradually thawing out. I had a chance to see this firsthand when I gave a talk in Krasnoyarsk in Russia. And I talked to the people there, and they said, yes, they actually like global warming because it means that the climate is not so cold. And Ice Age animals are coming back that were frozen, but now are melting and are being retrieved by scientists. In fact, there's one mammoth, a near complete mammoth carcass frozen in the ice, which is gradually melting. So is it possible to extract DNA from them? Well, they have extracted pieces of DNA. Now they're using computers to put them together like a jigsaw puzzle. And yes, they do believe they can bring back the mammoth. The DNA from the mammoth would then be inserted into a female elephant who would then give birth to a baby mammoth. And then the question at Harvard that was raised is it ethical to bring back the Neanderthals? Because after all, we have now sequenced the DNA of Neanderthals, and in principle, it's possible to insert that DNA and give birth to a live baby Neanderthal. This was worked out at Harvard University. They haven't done it, but they say, yes, in principle, it's probably possible. But then that raises ethical questions. Some people have asked the question, what do you do with a young Neanderthal kid? Do you put him in a zoo or do you send him to Harvard? Big question. And then the question is, what about the dinosaurs? Well, these animals that we're talking about are Ice Age animals that go back 10, 20, maybe 50,000 years into the past. But dinosaurs, well, dinosaurs died out 65 million years ago. However, there's a glimmer of hope. Several years ago, scientists cracked open the thigh bone of the hadrosaur, and what did they find inside? Much to their shock, they found soft tissue. This was not supposed to be possible. It was once believed that dinosaur bones are completely fossilized, they're mineralized, 100% minerals. All the DNA has been replaced by minerals. But no, by cracking open the thigh bone of the hadrosaur, they found soft tissue. Then they analyzed the chemical composition of the soft tissue. They did not find DNA, unfortunately, but they found protein fragments of protein molecules, and they compared these molecules to molecules of proteins of animals today, and they found a resemblance to the DNA of frogs and turtles with the DNA from the dinosaurs. Since then, they've cracked open the thigh bones of other animals, and sure enough, they have found other evidences of soft tissue that has been hidden inside the skeletons of dinosaurs. Now, does that mean that one day we can bring back a dinosaur? That's still a long shot. If you saw the movie Jurassic Park, they bring back the dinosaurs because by chance they were able to find mosquitoes that sucked the blood of dinosaurs that were then encapsulated and then preserved in amber for over 65 million years ago. Well, so far we have not found evidence of that, but you can't rule it out. I mean, even the idea of bringing back the Neanderthal was once considered totally science fiction, but now, yeah, it's something that scientists have looked at, and we realize, yes, it could be possible. We should also point out that ancient diseases are now being analyzed, and we're now able to fill in the blanks of ancient history and modern history. When you take a look at the Irish potato famine, for example, the famine of the 1800s was so severe that the population collapsed in Ireland. Millions of people left, to the point where in America, you can find a city in America which has more Irish people than Irish people in Dublin. And so we have the enormous scars left over by ancient diseases. And scientists recently have sequenced the genes of the fungus that was responsible for the potato blight. There were many theories beforehand, but now they've actually been able to get back, analyze remnants of the potato famine and use modern DNA sequencing to once and for all identify the culprit that caused the collapse of the Irish economy. I should also point out that there's some dangers involved. In 1918, we had the Spanish flu virus that actually killed more people than World War I. It is one of the greatest killers in the history of the human race. And the people who sequenced the genes of the Spanish flu virus did something that a lot of scientists, myself included, feel very uneasy about. They sequenced the genome and then they published it. That's right. One of the greatest killers in the history of the human race, its genome has been published so that in principle, a renegade scientist or renegade country would be able to resurrect this virus and unleash it, which would then be responsible for the deaths of hundreds of millions of people. It really means that we have to be very careful when we sequence the genes of these ancient diseases and then publish the genome, because in the future, perhaps high school kids will have a typewriter by which they can print out ATCG, ATCG, and create their own virus for a summer school project. It turns out that with CRISPR technology, we're able to edit DNA much easier than previously thought. And then the question is, what happens if teenagers get a hold of this technology? Well, that is something to think about, because that day could be coming. The day when even teenagers will be able to perform genetic engineering. Well, I'm afraid that's it for exploration. Good day.